Okay, so if you guys recall from page 29 in the notes, we had to find the derivative of the following function. We had the function f of x was equal to x over root 1 minus x squared. And so how do we take this derivative? We could use the quotient rule, right? And then we could rewrite this as like h over a function g, right? And if you recall, quotient rule became g times h prime over g squared minus g prime times h, right? But doing it that way might actually be a heck of a lot of work. Instead, you might think of this as a product, because I can rewrite this in the following way. I can write this as x times this 1 minus x squared to the negative 1/2 power. So here, this becomes h times g, in which case its derivative will become h prime g plus h times g prime. This might be a lot easier to deal with. So let's do it both ways. Let's do it the hard way first, and then we'll try the other way. So, quotient rule. Let's see. So we've got g times h prime up top. Let's put the denominator first, right? The denominator is just that square root of 1 minus x squared, but it gets squared, so we just end up with a 1 minus x squared. But now we've got root 1 minus x squared times the derivative of h, which is just 1. Easy so far. But now we've got to multiply by g prime. Well, what's g, right? G is equal to 1 minus x squared to the 1/2. So g prime, what is that equal to? Well, if you notice here, I've got some function raised to a power. We've got to use our chain rule along with the power rule. So by the power rule, right, what was the rule? We had to pull the 1/2 out. The inside stays unchanged, and then we subtract 1 from the power, giving us negative 1/2. But now we've also got to take, due to the chain rule, the derivative of the inside. What's the derivative of 1 minus x squared? That's negative 2x. So if we simplify this, the derivative of just g is going to give us this negative x over root 1 minus x squared. Okay, so now we can plug that back in. So we get a negative x over root 1 minus x squared times h. H was just x. There we go. But that looks a little bit messy, right? We've got to clean. So if we multiply top and bottom by root 1 minus x squared, it's like we're multiplying by 1, right? Notice if we distribute the root 1 minus x squared to this one, that just becomes a nice 1 minus x squared. Minus now this one, when we distribute this to that one, right? Basically, we get 1 in the numerator and 1 in the denominator. They cancel each other out. If we distribute the negative signs, that takes us to a positive x squared all over. But now this times this, they have the same base, right? They have that same 1 minus x squared, but this one's to the 1 power, this one's to the 1/2 power. So if you guys recall your algebra rules for multiplying things with different powers, but the same base, we get a 1 minus x squared to the 1 plus 1/2, or in other words, 3/2 power. And then we could simplify this even further, right? Notice we got a negative x squared and a positive x squared. That gives us 1 over root over 1 minus x squared to the 3/2. Okay, so there's the answer, right? There's f prime. So we'd say f prime of x is equal to, right, this thing down here. But now, could we have done this a different way? Can we try and do this using the product rule? So now here, right, if this is, we can rewrite this as x times 1 minus x squared to the negative 1/2 power, right? So this is now h times g, and its derivative, as we said before, was h prime g plus hg prime. So let's take its derivative. Derivative of x, just a 1, nice and easy, times the original, 1 minus x squared to the negative 1/2. Now we're going to add that to h times g prime, so here's h. But now what's g prime? If you recall, we took that derivative, right? We had the power rule, the negative 1/2 comes out, times our 1 minus x squared to the negative 1/2. Oh, what did we forget to do here? We got to subtract 1 from the power, right, for the power rule. So we get a negative 3/2 here, times derivative inside, right, by our chain rule. And that was a negative 2x. Okay. That doesn't look exactly like our previous answer, right? But maybe we can convert it so it looks the same. So now let's rewrite this. This part, right, if we're to a negative 1/2 power, this is equivalent to right, 1 minus x squared to the positive 1/2 if it's in the denominator. So here we have that 1/2 in the denominator. Okay, now over here we've got a negative and a negative. This canceled, right? The 2 over the 2, that reduces, and x times x, so that gives us x squared over, and now this is 1 minus x squared to the 3/2 power. And now we notice they have the same denominator, but not the same power, right? So, or same base, right, but not the same power of each. So, okay, this one's to the 1/2 power in the denominator. So if I multiplied top and bottom by 1 minus x squared, then this will now be to the 3/2 power, right, if I multiplied top and bottom by 1 minus x squared. Now we've got a common denominator. Notice I've got a negative x squared and a positive x squared, so those cancel. And I end up with what I had earlier, which was the 1 over 1 minus x to the 3/2 power. And that, again, was our f prime of x, using both the quotient and the product rule.